Welcome to Algebra 1, Unit 7, Lesson 22, Practice Problems. We have one vocabulary term for this lesson, and that is vertex form of a quadratic expression. The vertex form of a quadratic expression in x is a times x minus h squared plus k, where a, h, and k are constants and a is not 0. If you have any questions about this vertex form of a quadratic expression, please ask for clarification before we begin the practice problems. So in our first practice problem, it says the following quadratic expressions all define the same function. First, they've given it to us in factored form. Next, they've given it to us in standard form. And third, they've given it to us in vertex form. And each of these forms is handy for finding something different. So the factored form is used to find x-intercepts. We take each factor and we set it equal to 0. First, x plus 5 equals 0 when x equals negative 5. So our first intercept is at negative 5, 0. The other is when x plus 3 equals 0, and that happens when x equals negative 3. So our other x-intercept is negative 3, 0. And if you notice, this matches choice C. The x-intercepts are negative 5, 0 and negative 3, 0. The next form is standard form. And this is great for finding the y-intercept. Because when we have the y-intercept, or when we have the standard form, the y-intercept is the c portion, or the constant portion. So 15 is our y-intercept, so our y-intercept is at 0, positive 15. So if we scroll down, we see that this matches choice F. The y-intercept is 0, 15. And the last version they gave us was the vertex form. And as the name implies, the vertex form gives us the vertex. So if the vertex form is x plus 4 squared minus 1, remember the x-coordinate is the opposite of what is inside parentheses. So that would be negative 4. And the y is exactly what's outside parentheses. So that would be negative 1. And you can see that this matches choice B. The vertex is negative 4, -1. So the correct statements are choices B, the vertex is -4, -1. C, the x-intercepts are -5, 0, and -3, 0. And F, the y-intercept is 0, 15. If you have any questions about how to use these three different forms to find these points, please ask for clarification now before we move on to the next practice problem. At the top of the back page, it says the following expressions all define the same quadratic function. So again, first they give us factored form. Next, they give us standard form. And third, they give us vertex form. Number 1 says, what is the y-intercept of the graph of the function? If I want the y-intercept, then I want standard form because the c, or the constant, is my y-intercept. So my y-intercept is at 0, -24. And we could go ahead and graph that point right here where I'm putting the blue dot. Number 2, what are the x-intercepts? Well, if I want the x-intercepts, then I want to use the factored form. And I set each factor equal to 0 and solve for x. So when x minus 4 equals 0, x must be 4, so that intercept is at 4, 0. So we can plot the first x-intercept where I'm putting this red dot at 4, 0. The other factor is x plus 6, and when we set it equal to 0, x must be -6. So the x-intercept is at -6, 0. And we can go ahead and draw that point right here where I put the second red dot at -6, 0. And number 3 wants to know, what is the vertex? Well, if I want the vertex, then I'm going to use the vertex form. I want the opposite of what's inside the parentheses. So for number 3, my vertex is at -1, and I want exactly what is outside the parentheses for y, so that's -25. And I'm going to put a point at -1, -25, right here where this orange dot is. And now number 4 says, sketch a graph of the function without graphing technology. Make sure the x-intercepts, y-intercept, and vertex are plotted accurately. So we already plotted the x-intercepts in red, the y-intercept in blue, and the vertex in orange. So now we just need to connect these points and continue the parabola. And this is how you can graph your quadratic equations. If you have any questions about how to use the factored form to find your x-intercepts, your standard form to find your y-intercept, or the vertex form to find your vertex, and then graph the parabola, please ask for clarification now before we move on to the next practice problem. Middle of page 2. Here is one way an expression in standard form is rewritten into vertex form. Number 1. In step 1, where did the number -7/2 come from? This comes from taking b and dividing it by 2. b was -7, so it was -7/2. Number 2. In step 1, y was -7/2 squared added and then subtracted. It was added to complete the square, then subtracted to keep the overall value the same. Because if you add an amount and then subtract that same amount, you're really not changing the value. They cancel each other out. Number 3, what happened in step 2? In step 2, x squared minus 7x plus -7/2 squared was rewritten as a perfect square. Number 4, what happened in step 3? 6 was rewritten to have a denominator of 4. That way we could subtract 49/4 from it. And number 5, what does the last expression tell us about the graph of a function defined by this expression? The last expression is written in vertex form. It tells us the vertex is that we want the opposite of what's in parentheses. So that's 7/2. And we want exactly what is outside the parentheses. So that's -25/4. Or if you want to write it as a mixed fraction, this is 7/2 and -6 1/4. These are the same point. If you have any questions about how to change from standard form to vertex form so that you can use the standard form to identify the y-intercept and then use the vertex form to identify the vertex, please ask for clarification now before we move on to the last practice problem. And at the bottom of page 2, we have our last practice problem. They want us to rewrite each quadratic expression in vertex form. So number 1 is the simplest. We have d of x equals x squared plus 12x plus 36. Well, this is already a perfect square. I'm just going to rewrite this as x plus 6 squared. So my vertex the x coordinate is the opposite of what's in parentheses, so that's -6, and it's exactly what's outside the parentheses, which is 0. So my vertex is actually at the x-intercept at -6, 0. So this parabola would have its vertex on the x-axis at -6, 0, and then open up away from the x-axis. Number 2, we have f of x equals x squared plus 10x plus 21. This is not a perfect square, so we are going to take 10 and divide it by 2, which is 5, and square it, which is 25. And that's what we're going to add to complete the square. But if we add 25, we must also subtract 25. So now we can write this as a perfect square. So it becomes x plus 5 squared, and then 21 minus 25 is -4. Now we have vertex form, and our vertex is at the opposite of what's in parentheses, so -5, and exactly what's outside parentheses at -4. For number 3, this is a little bit different than what we've done before, because now we have a 2x squared. So we have g of x equals 2x squared minus 20x plus 32. So, the first thing I'm going to do is factor a 2 out of this 2x squared and this negative 20x. So now I have 2 times x squared minus 10x, and my plus 32 is on the outside. Now, I'm going to take this negative 10 and I'm going to divide it by 2. So that's negative 5. And then I'm going to square it, and negative 5 times negative 5 is plus 25. But if I'm adding 25 in parentheses, when I multiply it by the 2 outside of parentheses, I'm actually adding 50. So if I'm adding 50, I also need to subtract 50. This way I don't really change the value. I add 50, then I immediately subtract 50, and it's right back to where it was in the beginning. So now I can write this in perfect square form. We've got 2 times x minus 5 squared minus 18, because 32 minus 50 equals negative 18. Now I know that my vertex is at the opposite of what's inside parentheses. So instead of negative 5, it's at positive 5. And it's exactly what's outside parentheses. So the y coordinate is negative 18. If you have any questions about how to rewrite standard form quadratic equations into vertex form quadratic equations, please ask for clarification now before we move on to lesson 23.